So we're to graph these. Let's do this in pieces. First of all, we're going to find the vertex. When vertex form, here is the x and the y for the vertex. Remember, the vertex form has subtraction built in, so the h is 3 and the y or the k is 8. So the vertex is 3, 8. And I would plot that first. Next, the axis of symmetry is the middle of the parabola. If you notice, y changes as I go up and down on that blue line, but x never changes. So the equation for that line is x equals 3. Vertical lines are always x equals some number. So don't forget, 3 is a number, x equals 3 is a vertical line. Okay, let's do the easy one. To find the y-intercept, we said that x has to be 0 because it's on the y-axis. So I plug in 0 for x and work it out. I get -9. And so the y-intercept is 0, -9. And so that's down here. Now let's see if you understand what we mean by axis of symmetry. If I have a point 0, -9 down here, and this is the axis of symmetry, should there be a twin point on the other side, which would be 6, -9? And so we can get another point quite easily just by using the idea of symmetry. To find the x-intercept, we want y to be 0. So in this equation, y is 0, and I have the rest just copied. I'll bet you most of you want to just multiply that out. Let me give you a suggestion. Let's subtract 8 from both sides. Now let's divide both sides by -2. In other words, we're going to isolate the squared expression. Now, I can square root both sides to get rid of the square, but you remember I have to include plus or minus because if I square 2, I get 4, but if I square -2, I also get 4. So this package deal here could either be 2 or -2. And that's why I write this. The x minus 3 package could be 2 or -2, because squaring it in both cases will give you 4. So add 3 to get x by itself. If I add 2, I get 5. If I subtract 2, I get 1. And so our x-intercepts are the points 5, 0 and 1, 0. And sure enough, they are twin points on either side of the axis of symmetry. And that gives us 5 points. Should be good to go. Left to right, I go forever. Bottom to top. Remember, go from bottom to top for the range. That's from -infinity up to 8. Domain goes with x. Range goes with y. Domain is left and right. Range is bottom to top, not top to bottom. All right, same thing here. Remember, subtraction is part of our formula, so I must have subtracted a -2 to get +2, and so the x-coordinate of the vertex is -2, the y value is 2. Our vertex is -2, 1. The axis of symmetry goes straight through the vertex. It's always x equals -2. The y-intercept is pretty easy to find. You plug in 0 for x, because on the y-axis, x is 0. Square it, add 1, we get 5, and so 0, 5 is the y-intercept. Immediately, we can get the twin point on the other side of the axis of symmetry, and that point is -4, but also 5. If you understand what's going on here, there isn't going to be an x-intercept, because here's our vertex, and the a value is positive, so it goes up, and so if it goes up from that point, it's never going to hit the x-axis, and there's no x-intercept. But if you plug in y is 0, and solve, we'll use the same method. We'll get the squared thing isolated, and squaring something to get a negative, not going to happen unless you talk about imaginary numbers. So left to right, forever, negative infinity to positive infinity, bottom to top is from 1 to infinity. And I include the 1, that's why the 1 has a bracket. Okay, now let's talk about equations in standard form. Unfortunately, in standard form, we can't see the vertex, and so we don't have a good place to start yet. But last year in Algebra 2, when you talked about parabolas, you found the x-coordinate of the vertex by using this easy to remember formula. The x-coordinate of the vertex is -b over 2a, where the a, b, and c come from the quadratic formula numbers. So let's get started. So here's our quadratic function. Define the vertex. Let's take -b over 2a, and this will give us -4 over 2 times -2. 2 times 2. And that's -1. So the x-coordinate of our vertex is -1. To find the y-coordinate, we just plug in the x values here and here, and we'll find the y-coordinate of that x value. So we plug in the -1 here and here, and work it out from left to right, watching for the order of operations, and we get -5. So our vertex is -1, -5. Again, quickly, the axis of symmetry is very easy. It's just right through the vertex, and it's x equals -1. Now, we have our equation pretty much in vertex form, because, yes, we have our vertex, but this a value we already have from the original equation. To find the y-intercept, plug in 0 for x, and I would plug it into the standard because it's easy, because this is 0, this is 0, and I just get -3, and there's our y-intercept, 0 and -3. And quickly, we can still do the twin point. That's on this side. That's on the other side of the axis of symmetry. So that's -2, -3, and we have another point. Unfortunately, the x-intercepts here are not nice. I go ahead and plug it into the quadratic formula because I'm looking for the x-intercepts. Y is 0, and it's the quadratic equation. And I go through plugging in the numbers, cleaning it up some. Don't forget, when you get to here, you can take out a perfect square under the radical, which is 4. 4 times 10 is 40. 4 comes out as a 2. And then when you reduce, think of this 4 as a common denominator. Here and here, it would just cancel. And so everybody can be reduced by 2. Here are the decimal approximations using my calculator, and here are the approximate positions for the x-intercepts. Again, the domain goes forever from left to right. The range goes from bottom to top, including the -5. Example 6 is much the same. They give us the equation in standard form. To find the x-coordinate of the vertex, we take the -b over 2 times the a, and the a is -1. 2 over -2 is -1. That's the x-coordinate of the vertex. To find the y-coordinate, I just go ahead and plug in that x value here and here. Watching the order of operations, of course, we square first, and then a negative times a negative is a positive. From left to right, we get 2. That's the y-coordinate of the vertex. -1, 2. The axis of symmetry goes right through the vertex. And it's always x equals. In this case, it's x equals, -1. Let's correct that. And then now we basically have our vertex form. The a value is -1 from the original, and we just found the h and the k. Again, as a reminder, the formula has subtraction. If I subtract a negative, I'm going to get an addition. Y-intercept is easy to find. If I plug it into the original standard form, x is 0, this goes away, this goes away. The y-intercept is 1. Now be careful, in Algebra 1, you call the y-intercept b. Y equals mx plus b. But for the quadratic formula, who is this? Isn't that c? So be careful. But you're right, it's the number by itself. It's still easy. Y-intercept is 0, 1. And because of the twin point idea and the axis of symmetry, the point on the other side of the axis of symmetry is -3, 1. We can get that almost immediately. Unfortunately, the x-intercepts are still ugly. We take the standard form, pop it into the quadratic formula, clean things up. Don't forget the square root of 8, well, there's 4 times 2. The 4 is perfect. That comes out as a 2. And then I reduce each of these individually. It's a common denominator. 2 over -2 is -1. And if it's plus or minus, it really doesn't matter if I divide by a negative or a positive. It's still plus or minus. Here are my x-intercepts. And again, we approximate them and draw our parabola.